I have a lot of slides here, and I'm not going to go into all of them. Luckily, a lot of this we've actually already talked about. I'll try to make sure that I don't gloss over anything that hasn't been mentioned so far, and especially the results of the landscape trials and the biodegradation trials. We look at round 2 landscape trials first, but I should mention that in the first round with those 30 plus containers, we had 3 treatment types in the landscape where we were evaluating transplant establishment and even fruit growth on the pepper and tomato with treatments planting the plant with the container on, removing the container and discarding it for the second one, and removing the container, crushing it, and burying it beneath the plant when we installed it. And based on our results, I wouldn't recommend that you leave a container on anything. There was one that we didn't find a statistical difference in, and that was the wood fiber container that was uncoated. Other than that, we did see a statistical difference in the health and growth of all of the containers if you left that container on. So I know it's kind of a gizmo that they want to try to promote, leaving that on there, but I don't see the value in it. It's just a quick thing to take it off. If it's going to slow it down, then just take it off of there. In the second round, generally,
It's slowed in like, a few months after you were evaluating? Or?
well, just the measurements at 8 weeks,
8 weeks.
Both size and health ratings.
Okay, so you don't know how long that affects?
No, and it didn't seem to be quite as bad with tomato, believe it or not, because we buried that container down in the soil farther, and the roots came out over the top.
Okay.
But we did find statistical differences for every single type, except for that wood fiber.
I want to ask on that, was it health issues or growth issues?
I guess I'd have to look back at my results. I think it was more the growth. Once we got to there and found that, we're like, well, we won't be using that anymore. But I just wanted to mention it, that we're not recommending that anyone leave these containers on, even though this is part of our system.
Any woody species?
Not in these. We have woody species in the landscape right now that we finished the season with, but we haven't taken any measurements. And honestly, I don't expect to see any differences because they were so uniform.
Yeah.
They were just really well done.
Yeah,
None of those
about not having a bunch of nursery.
Right, yeah, so we apologize for that, but they just all did well. That didn't include any of the ones with fertilizer effect. Just the ones that you see back there that, are more durable and less degradable, and we were able to actually make them in the mold this year. But most of those materials are more inert. They'll grow pretty much just like a petroleum pot.
So what if you did some sort of method to just make some sort of break in the pot or something before you potted it or something, so that it does degrade in there or something?
That's a possibility.
Yeah.
Honestly, based on these results here, which I probably won't go into depth too much, we're not quite sure where we would want that material at this point. As you can see, there were no statistical differences within each column. With the container discarded, within that column there were no differences from the control that was also discarded. Within this column, there were no differences from the control, except the PLA, soy, and DDGs, which was our top one. And it'd be hard to deny that there was a good fertilizer effect in the landscape there. But not all of the ones that provide fertilizer did the same thing. None of these were statistically significant. Generally, there was an increase if you left that container, or if you broke that container and put it in the soil with it. Only 2 of them within a container treatment showed an increase, and that was the PLA soy and lignin, and this uncoated paper fiber showed a statistical increase. This one, my theory is that you have evaporation through the container and it concentrates fertilizer salts in that fibrous material, and then when you break it and put it under the plant starts to get back some of that fertilizer that was wasted during production. And since we removed it here, it didn't have that available. So the lack of significance here makes us not certain about the practices we might recommend, where if it is a biodegradable pot, it might not need to be near the plant because it may not give much of fertilizer after it's transplanted into the landscape anyway. When we get more containers, we'll do this with higher numbers and maybe just one species with really high replication or something, to see if we can find more of those answers. But it's pretty safe to say that putting any of these materials near the plant roots is not harmful. Either fairly inert or providing a little bit of nutrients and definitely not overpowering anything. Moving on to biodegradation in soil. Do this a little differently. I'm going to show the second round first, because with the first round ones I have both 6-month and 1.5 year results. This is 6-month results with the improved containers from this year. Little different than Kenny's. I put the petroleum plastic control on the top, which isn't going to mean much in this one anyway because there's no degradation there. But what I do want to show you is that the ones that within 6 months in the soil also didn't lose any mass by degradation. And one is that PLA composite with lignin. Recycled PLA does not degrade in the soil. Others with the K. Polyamide with lignin, polyamide with PLA. All of those are quite stable, durable. You can, your cultural practices can be the same as petroleum plastic, but they don't degrade in the soil. With the polyamide, we've been saying all along that's not degradable. We did get some degradation with 30% DDGs, but as you can see, that's less than its weight amount in there. These were 30% by weight, and we only lost 20% in 6 months, so it wasn't even quite keeping up. But some of these, like the PHA composites with DDGs at 20%, we had 47% degradation in 6 months. A very similar material with starch at 10% was only degraded 15%. And I'll show you a little more from last year's, but that DDGs has a really nice effect on the degradation of PHA. Even though these containers held up for 16 weeks quite well in the greenhouse, when we put them in the soil, the organisms there and having the activity all the way around that material helped those to degrade. When I said we had accomplished that original goal, this is the container right here, PHA with DDGs. Looking at the PLA composites, here's the one with 50% soy, and that degraded this year at 45% within 6 weeks. The 33% soy you know, comparable to the amount that's in there. Something with those composites, when that soy degrades out of there, you're left with the PLA, but it's almost like a wafer. I mean, it feels lighter than it should feel. It's kind of strange, and even though our samples are precious to us and we haven't done this yet, when we get to do this with more materials, we'll just, I'm pretty certain that you could just take that after 6 months and just crumble it into small pieces. I guess we'll just move on from there. Here's that Aspen Research container. Not quite as fast of a degradation as the 50% soy. Just to look into it a little bit more using the results from the first year container materials for degradation over 6 months and degradation over a year and a half. And I've come to think about these as growth seasons, because at 1 year, when we dug these up in the spring, they hadn't lost anything more than they had lost in my last extraction in the fall. So the winter pretty much stopped degradation of everything. And that's why it's going to be a climate thing. We have the best soils in the world in Iowa, but we have this winter that stops everything. If this was down in, say, Alabama or Mississippi, these numbers here might have been at 1 year rather than 1.5 years. Again, you know, the petroleum plastic didn't degrade, and within each column, the ones that are shaded were also not different from that control. So to look at those first, PLA polymer without any composite material doesn't degrade. PHA with the polymer only in 6 months was only 8%. So that's actually the first time you're seeing this PHA with polymer only, because in the second year we included DDGs, or the one with starch. And then down here, which was a really big surprise to us, the terrace shell pot from Summit Plastics, it grows plants really well. You don't have to change your practices at all. It's really light, it's thermoformed, and the price was good. And they've sold every unit that they've made every year. But it has biodegradable molded right into the side of the container, but at least by our definition, we want these to be gone at least within 2 years, and it's just not going to make it. In the first year, it wasn't statistically different from the control. The second year, it was only about twice the percentage that had been lost. It's losing its integrity, like I can see that, but it hasn't lost weight, you know, with our methods. PLA composites with soy at 50%. Last year, I think our degradation was a little bit faster because it was a warmer season. We irrigated these at 1 inch per week regardless, and we had warmer temperatures, so the activity was probably quite a bit better. But here's a plateau. PLA with soy at 50% loses all of the soy, most likely, but then after the second season, it was only 54% compared to 53%. So this is one of those philosophical things that maybe we can discuss at the end.